Hello and welcome to the eTech podcast with me, your host, Ryan Morn. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. Today's podcast is something a little bit different. It's another one of our keynote speeches. So this is from a conference a couple of weeks ago in Stuttgart. I was lucky enough to be invited to talk at this conference. This is the Eevee battery show. So this has gone from being a really small event a few years ago to now being a very significant event in the EV world. Lots of vehicle manufacturers attending, loads of component suppliers, everyone getting together and talking about the future of the EV industry, the components, the hardware, and what's happening. So it's a great event for us. Really interesting conference session that goes alongside it. Some really technical talks. My talk at the conference was about the key trends that we see in the market that drive different kinds of electrification. So always quite keen to point out that it's not just about battery electric, which is great. You know, we love battery electric, but there's other kinds of electrification that can be really big help as well in terms of reducing emissions and improving the efficiency of vehicles. So without further ado, let's get on with it. Here is today's podcast for you. Thank you. This presentation is a bit different. So we've got a fairly high-level canter through some trends in the commercial vehicle or heavy-duty vehicle electrification scene that we are seeing as a business at the moment. So just a really quick introduction to Avid technology. Basically, we have three core competencies: thermofluids, high-power density motors, and power electronics. We're quite a small, innovative, and agile business. We have a range of platform products, and we're dealing in the heavy-duty and high-performance vehicle space. So quite a good selection of customers. So I guess in contrast to the last two presentations, I'm going to talk a bit more about the general electrification scene. So what do I mean by that? We see some key trends in terms of the big question, which is why. So why are we electrifying in the first place? And those trends drive how we electrify, because it's not just about battery electric. So I think when we're talking about electrification, we can get very into fully battery electric, but obviously there's a lot of other powertrain topologies, and particularly for the commercial vehicle, heavy-duty vehicle space, there's a lot of other powertrain topologies which are very appropriate and bring some significant benefits. So the first trend, it's fairly clear, is clean air. So very aware of this now. We have a lot of activity globally to do with clean air, basically in the wake of the diesel scandals that have hit the automotive industry. That's made legislators very, very aware of the clean air situation. So if we want clean air, we want zero emission operation, and driven by the legislation, it's kind of the cost is not necessarily the key driver. And that's unusual because typically, commercial vehicles are different to passenger cars. You might buy a Tesla because you want to impress a potential boyfriend or girlfriend, but you don't buy a truck to look cool, or unless it's a big rig to take and show your friends. You buy a truck to make money. So the cost of ownership is really important. And what we can still see, even today, with the costs have gone the way they've gone, the total cost of ownership argument is difficult for fully electric vehicles in most applications. But where we have the extra lever from government to incentivize fully electric operation, and we're increasingly seeing that for different reasons, because of clean air, because the governments have recognized there's a social and economic cost to air pollution, so they're prepared to invest in and incentivize zero emission operation vehicles. So that basically comes in 2 or 3 different flavors. One of the things, if anyone who knows me knows, I find the sort of argument between fuel cells and battery electric quite entertaining. So we like fuel cells; they do solve some issues in the market. But basically, a fuel cell vehicle is an electric vehicle, so we like We like it all. But essentially we've got fully battery electric and zero emission capable hybrid vehicles filling this space in the market. We definitely have a cost up on the vehicle powertrain. We definitely have some difficult maths to do in terms of the total cost of ownership calculations, and we're basically relying on legislation. But the good news is, if you're involved in making components and powertrain systems for this kind of vehicle, there is more and more legislation coming through that is driving this. So we are seeing a lot of investment around the world in vehicles and powertrains that can deliver. The typical the big cost item, as mentioned by the previous speaker, is the battery. And what we've identified here is basically the kinds of batteries that you'll see in these different applications. So ranging from high power, sort of 10C cells in the hybrid systems, or the fuel cells. Fuel cells effectively a hybrid. Relatively small batteries, up to some pretty massive batteries, so 300 kilowatt hours. Even bigger numbers being quoted now, so some pretty massive batteries, but with very relatively low C rates. So there's some interesting things happening there. And really the big one, and Daimler have made a lot of noises around this, is on the solid state batteries. So they've promised us that in the next year or so we're going to start to see solid state, very, very high energy density batteries come through in their commercial vehicles. So it's going to be interesting to see what's going to happen there. But as I mentioned before, the whole market isn't just about fully high voltage, high cost electric vehicles. There are other drivers. And the other key driver is CO2. So climate change, obviously. We talk about that now. We can talk about it more openly and not get laughed at quite as much, depending on which country we're in. But we're in Europe, so we can talk about CO2 and climate change. Electrification purely for CO2 is a thing, and if you think about it from a commercial vehicle point of view, CO2 is an output from the amount of fuel you burn. So it's essentially a measure of the operating cost of the vehicle or the machine. So where we have electrification purely for a fuel saving, which gives us a CO2 saving. So the marketing department of the company will talk lots about the environmental credentials and the CO2 reduction, but the fleet manager really only cares about the fuel saving. We have a different approach on the electrification. So we want to deliver essentially a solution which provides a total cost of ownership benefit to the fleet operator, typically in less than 18 months. So quite an aggressive TCO. And the previous speakers were talking about up to 4-year payback for fully electric. Most businesses that we are aware of, we deal with, it's typically 18 months or less, sometimes 12 months or less. So really the only way to do this at the moment is with mild hybridization. So we're going for lower voltage systems here with typically 48 volts. So even in very large commercial vehicles, we're able to deliver a good total cost of ownership benefit using a 48 volt mild hybrid system. And these are programs that we've been involved in the past. And we can see some really, really clear results. So in the sort of urban delivery truck type driving cycle, almost 30% fuel and CO2 savings with a mild hybrid. Very small battery packs, so very high C rates on the battery packs. So some quite particular challenges there. So these aren't commercial vehicles, clearly, but I like this slide, and anyone who's seen me speak before use it a lot. But a bit more sexy, electrification for performance. So e-machines are really, really good at delivering low-speed torque. McLaren P1 came into the market, blew everyone's mind in terms of the performance that you could deliver with a hybrid powertrain. And now, basically, if you're launching a supercar or a hypercar, it has to be a hybrid. So from all different manufacturers, new ones and established ones, and all kinds of different topologies. So fully electric, like the Rimac, or hybrid systems like McLaren or Koenigsegg, even down to 48 volt mild hybrid. So people don't realize, but the Ferrari LaFerrari is a 48 volt mild hybrid system. So a really high performance vehicle, but using fairly low cost e-machines to fill in the performance gaps in the powertrain. So whilst it's all really exciting and you can get lots of benefits in a hypercar, we do see that this translates into the commercial vehicle market as well. Because essentially what you're able to do now, instead of having 10 engines, is have 1 or 2 engines and provide different performance points with your electrification in your drivetrain. And we are seeing manufacturers do that. And obviously, if you're making a low volume of vehicles every year, there's some quite significant operational business savings that can come from having a more rationalized range of engines. So the electrification for performance angle gives us some nice products to look at, but in the commercial vehicle space, helps us to provide additional utility and rationalize platform engineering costs on the vehicles and the machines. And then the other big word is productivity. So this didn't mean anything to me until about a year ago, when a lot of our customers started to talk about productivity. Now, there's some examples on this slide of machines that are electrified and actually have been for a long time. So, we talk about electrification as a very new thing, but if you went to a lot of open pit mines, open cast mines as they're sometimes called, even 20 years ago, you'd actually find electric powertrains in the haul trucks and some of the other machines that are used. So the basic reason for that is actually quite cost effective in the very large equipment and low volume production to deliver an electrified powertrain compared to a mechanical powertrain, because of the low speed torque delivery and the more simple kind of driveline that you can achieve with an electrified machine. So these products have been around in the marketplace for quite a long time, and some of them sell better than others. But one thing that you do find when you start talking to the manufacturers is actually there are particular reasons why their customers buy these products. So the D7E and the John Deere machine there, they talk about increased productivity. So actually the customer buys this machine because it delivers an operational benefit. It's easier to drive, it's easy to operate, I can move more earth, I need a lower skilled operator to be able to drive the machine, and that has some other cost savings for me as a manufacturer. One of the big things about these though, they don't tend to have battery packs at the moment, although we're seeing some movement on that in terms of bringing in some energy storage. So they're not even getting the benefit of regeneration and of deceleration. You never really get that in the dozer. But they are quite simple drivetrain layouts. We'll see some huge batteries and some huge energy storage systems starting to come into these, but it's all driven by the total cost of ownership. There's no incentive for these manufacturers or for their customers. There's no sort of mandatory legislation to force them to go zero emissions. So it's all about delivering a cost saving for the end customer. We have a very sort of particular set of characteristics in the heavy duty market. Like I said before, you don't buy a truck to impress anyone, you buy it to make money. So total cost of ownership really is absolutely everything. The purchase price of the vehicle or the machine is not always that significant in terms of the operating costs. So you have depreciation, maybe a 5 or 10 year asset life. That is a significant chunk of the cost, but it's typically not the biggest cost. Your other large cost items are your fuel, your operator, so your driver cost, and your maintenance. And really blending all these things together does drive some quite complicated total cost of ownership calculations. And we are starting to see applications where fully electric can deliver total cost of ownership benefits. So particularly in things like transit buses, where highly transient operation, where really the service and maintenance costs start to get very high on modern low emission engines. Actually, the electrified powertrain delivers a very straightforward benefit in that case. In other applications, it's harder to see and actually deliver that total cost of ownership benefit. So the table there doesn't really show it very well here, but very complex set of TCO calculations to look at different use case scenarios for vehicles and machines to try and work out what an appropriate powertrain topology is. Essentially, it all comes down to the money. There's some particular challenges in the heavy duty market, and one of the big ones that we see at the moment is batteries and battery availability, and it's really changed. So the last 2 or 3 years, if you go back 3 or 4 years, we literally have cell suppliers contacting us all the time, trying to get us to take their cells, to test them, to integrate them into projects and put into new vehicles. Where we are right now is we have some Eevee and HEV programs with some very large global OEMs, and it's quite difficult actually getting the attention of the cell suppliers. So I think we're running a pass-through on a very, very significant project that would have been millions and millions of pounds worth of business for the cell supplier, recently, and out of 6 cell suppliers, only actually 1 of them was interested even in engaging with us on the project. So the availability of cells and the engagement from the cell suppliers is really, really difficult at the moment. We have also some issues in terms of the costing and the pricing of the cells. So we're sort of led to believe, it's $100 a kilowatt hour, $120 a kilowatt hour for passenger car cells. But actually, when you're buying and integrating cells at low volumes, the effective cost of the packs becomes much, much higher. We don't have a very high volume to amortize any development costs across. We've got some pretty significant test costs, so statutory testing for the battery packs to spread across a low volume. So the battery pack conundrum and the engagement with the cell suppliers is a very difficult part of the puzzle to overcome in the heavy duty vehicle market. And the lower the volume that you're developing in terms of vehicles, the harder that challenge becomes. So there are some solutions that can be used in terms of trying to help the battery system for the heavy duty market. So typically looking at trying to leverage capacity from the passenger car space. Now, Mihai mentioned at the start, commercial vehicles are very different to passenger cars. So you start out and you think, all right, I'm going to use some passenger car cells here. I can access the volume. I can access lower costs. I'll try and do a strategic tie-up with a cell manufacturer and use those products. And then as soon as you start to look actually at the life cycle use, the degradation characteristics and the requirements of the commercial vehicle market, you realize quite quickly that the products are at completely opposite ends of the spectrum. So unfortunately for a company like us, that normally means you're trying to balance the expectations of the customer who've got it in their head that they can get cells for $120 a kilowatt hour, but actually they want them to perform 25 times better than the standard that's produced for the passenger car market. So looking at ways to improve the life cycle and the performance of high volume passenger car cells is really key in terms of trying to leverage that scale and the volume, and being able to develop a battery pack using high volume, low cost cells, but that delivers the performance that's required for the commercial vehicle markets is quite a challenge. What we've found is that an awful lot of that, so probably 80% of that comes down to thermal management inside the pack, and there's a lot in terms of how you actually manage even down to the direction of heat transfer out of the cells. So in passenger car application, to be honest, it doesn't really matter. You can get away with very, very simple cooling, and even in vehicles that have, so if you look at a Tesla, for example, the actual installation of the cooling system inside the battery pack is very simple. It's basically some straight pipes that run in the vicinity of the cells, and you take heat out that way. So the pack, the internal thermal management system inside the pack is very, very straightforward. To extend the life of those same cells to suit a commercial vehicle application, you have to transform that thermal management system inside the pack to be able to take the heat out of the cells in a completely different way. So it's a very complex challenge with some significant engineering involved, which clearly then could also drive cost on the pack, which was said before, cost is really important in terms of then delivering total cost of ownership. So it's a very difficult area to overcome, but it's one that's being worked on constantly, continuously. So finally, just in conclusion, there's a lot of possibilities in the commercial heavy-duty market for electrification. We like to talk about beyond battery electric. So don't forget, mild hybrids and other electrified components in the powertrain. The drivers for the why tend to dictate the how. So why you're trying to deliver clean air, you have one approach. If you're trying to deliver total cost of ownership benefits, you have another approach. And you have to have that why clearly in mind in the design process to make sure that you take the correct approach. The market is very challenging commercially because of the fact that there's no kind of value to the style or the kind of the brand particularly. People are not buying these things for any other reason than to make money, to operate in their fleets. We can leverage some components from the passenger vehicle market, although I would agree with Mihai that you start to get the motors and the other components, it's not possible because of the different requirements, but it is possible with very careful battery management and careful thermal management within the pack to leverage cells from the passenger vehicle market. In the off-highway sector, actually, we're starting now to introduce cells from non-automotive applications. So there's a lot of cells coming into the market for industrial, powered outdoor equipment and this kind of thing, which are not certified and approved for on-highway use, but actually you can use it in off-highway application and do the same job. So that's all. Thank you for staying with me.
Very much. Yeah, we have a short Q&A now for the next 10 minutes. So yeah, like I said, if you have any questions, then please send them in. And one for you, Ryan. You mentioned, you quoted the regulations, the CO2 regulations that the European Union is put in, that 15% by 2022, I believe, and I'm not quite sure the numbers. But do you see that being the CO2 as the main sort of criteria, do you see then mild hybrids gaining more traction in Europe rather than battery electric, which may be more for the environmental, clean air driver?
Yeah, so it's a really interesting situation now with the new regulations coming through. So it's 15% by 2025 and 30% by 2030. And obviously commercial vehicles are already all high efficiency turbo diesel engines. So unlike the passenger car market where there was a shift from gasoline to diesel, we can't do that. So we basically have nowhere to go other than electrification. There are, within that system, there's effectively super credits for battery electric. So that will be a part of it. And I think that's going to end up benefiting manufacturers who have a wider portfolio of products. So where they're able to sell vehicles into applications that really suit fully electric, that's going to also earn them credits for their more conventional product. But basically, we will see electrification of varying degrees introduced onto almost everything. So, you call that mild hybrid as a system in Europe. We're also seeing a massive pull from the North American market as well. And I think the key difference that we forget about, so in Europe, the base electrical voltage is 24 volts that's used on trucks. So, 24 volt, you can do electrification around the powertrain of some of the more simple ancillaries at 24 volts and effectively have a micro or mini hybrid system. But we're still seeing 24, 48 volt hybrids coming. But in the US, where there's a 12 volt base electrical architecture, you're very, very limited in terms of what you can electrify on the powertrain. So we see a very strong pull from the North American market for 12, 48 volt hybrids, and there's some excellent solutions out there. If someone Eaton stand and someone else stand.
Great. So last year, DAF announced their electric CF truck, and this is extremely small range, extremely small battery, and some argued that it was not suitable for many applications. But then the sort of counter argument is it's really well suited for the application it's designed for. How do you stand on this argument? Do you think that electric trucks are going to get sort of narrowed towards a specific application to which they're going to be optimized for, kind of what you were saying with your optimization program? Or would you say that we have to wait until the trucks can really just cover all applications before they'll be widely adopted?
Like I said, it was a point I raised, and I think, certainly in this, where we're just about seeing the business case, like I said, you can't afford to carry excess capacity in terms. If you're running a vehicle with twice the capacity, his payback's going to be twice as long. So if you're only just starting to see the business case, it has to be quite bespoke in terms of how customised it is to the application. But then the volumes have to justify that investment in that topology to justify getting it out there in the first place. So I think we're at a current stage where there is potential for innovation, for kind of modularity, to allow manufacturers to do some scaling.
When you said future, some modularity.
You're not creating a custom solution for every single vehicle, which obviously is not going to be cost effective either. You need economies of scale, but you also want the scalability to be able to for different operation cycles, which you're inevitably going to have in multiple fleets and buses and trucks, to be able to suit them to what you're asking those vehicles to do to make the business case work.
Yeah. Would you two agree with that?
I think it's a bit like, you're in the gym and you see a fat guy on the treadmill. You don't tease him. You've got to start somewhere. So starting with kind of limited functionality or performance on a vehicle, there's a huge learning curve for the OEMs to go through. They don't know what they don't know yet, and they need to start that journey somewhere. Some have already started, but maybe haven't quite shown their hand yet to the market. Others have been very keen to show their hand with very early level vehicles. But you have to start somewhere.
Yeah.
I think what you do see in the background as well is, we get very hung up on the fully electric powertrain, but same OEMs have got some pretty significant mild hybridization in the background as well, which is very closely linked.
Yeah. What do you see in terms of the full hybrid versus the mild hybrid? Do you see them competing against each other or occupying different niches?
They occupy different niches, but they also compete. So the full hybrid comes, you get extra functionality, you get zero emission operation, but in effect you've got quite a significant cost penalty. I think the biggest, other than the actual purchase cost uplift on a mild hybrid, the other biggest benefit from a fleet operator's point of view, if you've got 2 trucks, actually installing some charging points in your depot and things is not a problem. If you've got 200 trucks, installing the charging infrastructure in your depot to overnight charge or off-shift charge 200 vehicles is very difficult, if not impossible at the moment. What you get with mild hybrids is the ability to have some electrification, a significant CO2 benefit, and you can do it now. You don't have to apply for a big fat electrical grid pipe or install local batteries or big capital projects or anything like that. It's ready to go now, basically. So the actual adoption is much smoother and frictionless for the fleet operator. It will come, but really the plug-in hybrid, you're only getting the full benefit of that if you can plug it in. High voltage hybrid, if you can't plug it in, the benefits over a mild hybrid are very marginal.
Do you see the sorry?
But to add to this point, I do believe that there are different niches. So it's going to be very hard to do a long haul full hybrid or Eevee because you'll be carrying a lot of batteries. There's no way around that. But it makes a lot of sense to do a mild hybrid in that application. Conversely, for a bus, the opposite might be true. But there are also synergies. So mild hybrids imply a certain level of electrical accessories at, say, 48 volt. That actually solves the problem for the fully electrical vehicle that needs all their electrified accessories. And if you have very few EVs, then the cost of the accessories is going to be prohibitively high. So mild hybridization actually becomes a stepping stone as a cost reduction, if you wish, for full hybrids by offering not all, but many of the accessories at significantly higher volume. So they actually also help each other.
Yeah, I agree.
This is all the time we have, I'm afraid. If you have any more questions, then feel free to come up to us and ask them personally. But thank you very much for coming, and I hope you had a good session.
Okay, so I really hope you've enjoyed that podcast. Don't forget to leave us a comment. If you've got any particular topics that you'd like us to cover, please you do send us an email or a message letting us know what you'd like us to talk about. We've got loads of really exciting podcasts coming for you. We've got some more interviews with some really big names in the industry. So don't forget to subscribe to our channel and leave us a rating. All right, I hope you've enjoyed today's podcast, and I look forward to talking to you again soon.